Howdy, today on Flippin Science we're looking at strong versus weak acids and bases. So the science understanding we're going to look at is that the strength of acids is explained by the degree of ionization in aqueous solution. So let's see what that means. So a strong acid is an acid that completely ionizes in solution. So a good example of this is hydrochloric acid. So if you put hydrochloric acid in water, it immediately breaks up into the hydrogen and chloride ions really quickly. And there's no hydrochloric acid stuck together remaining when this happens, or at least very few molecules. What that means is these hydrogen ions will then react with water molecules to produce hydronium ions really quickly. So we get a lot of hydronium ions present in their solution. Weak acid only partially ionizes. That means that only some of the molecules will break up into their hydrogen ion and the negative ion. So a good example of this is acetic acid, ethanoic acid. Only some of the hydrogen ions will break off of the ethanoate ions to produce the hydrogen ions that we need to make it an acid. Lots of the CH3COOH, so the still bonded ion here, the still bonded acid here, will remain in the solution. So let's have a look at some pictures here showing this. So here's our strong acid. We can see complete dissociation between the positive and the negative ion. If we look at our weak acid, we can see some of the acid is still stuck together. We have a few of the acid molecules which are broken up, but not many. So that's the difference between a strong and weak acid. A strong acid will completely ionize in solution, whereas weak acids will only partially ionize in solution. So let's look at some examples of strong and weak acids. So strong acids, I mentioned hydrochloric acid, sulfuric acid, which is here, nitric acid. And these are the main acids that we use in laboratories for that reason. They're strong. So we don't need to use much of them to generate a lot of hydrogen ions, which is what we're using when we're doing reactions with acids. Some common weak acids, we've got vinegar. So ethanoic acid in solution is vinegar. That's what vinegar is. Citric acid, which is found in lots of lollies. Phosphoric acid over here, that's present in soft drinks, as well as carbonic acid. They're both present in soft drinks. Phosphoric acid is used as a preservative. The carbonic acid, that's what you get when you dissolve carbon dioxide in water. So fizzy drinks are slightly acidic because of that combination of acids, but they're both weak acids. If they were strong acids, then you probably wouldn't be able to drink fizzy drinks. Now, it's very important that we don't mix up the idea of strong and weak acid with concentrated and dilute acids. A concentrated acid has lots of acid molecules in a certain volume of solution. So we'll look at concentration a bit later on, but a concentrated acid, large numbers of acid molecules in a small volume. The more acid you have in a small volume, the more concentrated the acid is. A dilute acid has very few molecules in a particular volume of water, and particularly dilute acids would have small numbers of acid molecules in large volumes of water. So if we have a look at our pictures down here, if the water volume is the same, then this is a concentrated acid because it's lots of molecules in it. This is a dilute acid because it has few. Now the problem is sometimes we mix up the words concentrated, strong, dilute and weak, but they have specific meanings when we're talking about acids and bases. So here are some more pictures summarizing these ideas. Over here we have a concentrated strong acid solution. It's concentrated because there's lots of acid molecules in here. It's strong because all the acid molecules have dissociated. So we've got hydrogen ions and the acid minus ions, the leftover negative part of the acids. Here we have a concentrated solution. It's got lots of molecules in the space, but it's a weak acid because we've only got some molecules that have dissociated, whereas all the rest of these ones haven't. So here we have over here a dilute strong acid, so it's a dilute acid because there's not many molecules in here in a particular space, but they have all dissociated, so that tells you it's a strong acid. And over here we have a dilute solution of a weak acid, so there's not many molecules in here, and only one of them has dissociated out of the four. So down here we have a similar idea. This is a dilute weak acid because only one of the guys is ready to go, and there's very few molecules of him, very few of him in the space. Over here we have a concentrated weak acid. We've got lots of the guys in the space, but only some of them are strong and ready to dissociate. So that's what they're sawed up. That's what that means. The same rules apply for bases. A strong base will completely ionize in solution. So sodium hydroxide, potassium hydroxide, pretty much any hydroxide they are strong bases because they completely ionize in solution, producing hydroxide ions. If we look at weak bases only partially ionize. Again, this time they're stealing the hydrogen ion from a water molecule and producing a hydroxide ion. That's what makes it a base, because we're making a hydroxide ion. It's also a base because it's accepting a proton, but because it's generating hydroxide ion, that makes it a base too. If we put ammonia in water, only a few of the ammonia molecules will steal those hydrogen ions from water molecules and generate the ammonium ion and the hydroxide ion. So because only a few of these occur for a certain number of the ammonia molecules, it's a weak base. So other weak bases are any amines, all your carbonates and hydrogen carbonates. They're weak. They don't completely ionize when you place them in solution. So we have a question here. I'm going to ignore the whole other column here, so just ignore that. The question is, in aqueous solution, classify these compounds as strong acids, weak acids, strong bases, or weak bases. And I'm just going to pick a few of these. So, is barium hydroxide a strong acid, weak acid, strong base, or weak base? Is this amine a strong acid, weak acid, strong base, or weak base? Is ethanoic acid, acetic acid, a strong acid, weak acid, strong base, or weak base? Is nitric acid a strong acid, weak acid, strong base, or weak base? Is phosphoric acid a strong acid, weak acid, strong base, or weak base? Is sodium hydroxide a strong acid, weak acid, strong base, or weak base? So let's go through those. So barium hydroxide is a hydroxide, so that's a strong base. This amine, all amines are weak bases, so that's a weak base. Acetic acid, ethanoic acid, is a weak acid. It only partially ionizes in solution. Nitric acid is a strong acid. It completely ionizes in solution to produce hydrogen ions and nitrate ions. Phosphoric acid is a weak acid. It only partially ionizes in solution. And sodium hydroxide is a strong base because it completely ionizes in solution, producing hydroxide ions. So today on Flipping Science, we looked at strong and weak acids and bases, and also the difference between strong and weak and concentrated and dilute. That's it for Flipping Science today. See ya.